Hi everyone, and welcome to another episode of Mr. Carlson's Lab. Today we're going to be restoring a BC-348-Q radio receiver from World War II. These radio receivers used to fly around in warplanes, and they needed to be very sensitive for very good reason. So what we're going to do is restore this radio receiver together, bring it back to life, and we'll test it and see how well it performs. So we're going to make this radio receiver perform the way it did when it rolled off the factory line. Let's get started. All right, let's see what we're up against with this radio receiver here. So this is the one that I chose out of all of them. There were some videos I did quite some time back about choosing the radio receiver to be restored, and I think this one here would probably be the best candidate to line up with the rest of the radio receivers. It does look the nicest, and it is, relatively clean inside. So first of all, the first thing I do notice is that in this radio receiver, somebody has added their own power supply in here, which was very common because these ran off a different voltage, right? Because they were on planes. So they've added a power supply which allows one to plug this thing in. So we'll see if that's even working. Yeah, just the standard stuff. Has a cable here. I imagine this is for the speaker, and we'll end up finding that out. Let's see if the thing even turns on. How does that sound? So what I'll do is I will plug this into the isolation transformer and current limited variac supply, which is right there, right here, looking at it on the monitor, pointing at strange things. Okay, here we go. I'll just get under the camera here and plug this in. Turn the variac down to the bottom, make sure it's on current limit, turn that on. And is the radio receiver on? It should be. So I'll just turn this up to about 3/4 of the way. Do we have any glow? We do have a glow going on the top there, which isn't too bad. So I'll duck under the camera here again, and let's see what we have going on. I do see dial lights. So this is the switch that turns it, off and on. So we have AVC, and then off is the radio, completely off, right? So we do have dial lights, as you can see here. So that's a good sign. Or any of the tubes lighting up is another sign. Kind of hard to see. I think there might be a bit of light in there. So we do have that. What would be very useful at this time is to have a speaker attached to it, wouldn't it? Let's see. I'll grab a speaker from right here. Let's see. Hopefully that is the speaker jack. I imagine it is. There's no reason it wouldn't be. All right. So, clip this into here. I don't hear anything. Lift this up to my head for a moment. It's pretty quiet. Turn that right up. Volume to the max. And not hearing. Usually you hear static or something in there, right? So next thing to do would be to attach an antenna to this portion right here. I see there's two pieces of copper sticking in there. So let's put that in here. I think I did that last time to prepare this. If I remember correctly, I grabbed a couple pieces of thick copper and put this in here to get it ready to do the restoration, and that was quite some time ago. Now I'm just beginning with this now. So let's put this on here now. I don't remember it coming with that, so I must have done that last time. Probably, what is it now, a year or so? Okay, so finally getting into this, right? Let's make this thing happen. So anything still coming out of here? As I hold this up to my head, it's getting close to the mic on my chest, so you'd hear it too. And I'm not hearing anything. So everything looks like it's normal, right? Yes, it does. Okay, well, the tubes even getting warm? Man, the tubes are just cold. So let's click it into bypass. It doesn't look like it's pulling too much current here. So if you see at the top, I'll zoom you into the bulbs. You can see the bulbs are just a kind of a nice orange. That's about it. On the top, just a gentle orange. If these things glow bright, like a normal light bulb, that means that there's something wrong in here. So I'll turn this right up. And they are glowing, but not bad. So it might look a little brighter than it does to me in the camera, but that's absolutely fine. So let's click it on a bypass and give it full line voltage and see what we got going on here. Well, the dial lights are nice and bright now, huh? Look at that. See if you can see a little bit more light in that tube. There is a little bit more filament glow there. And see, normally these tubes here, this is the audio output tube. Normally this tube here, if you were to put your finger on it, you would have some pretty bad burns. And this tube here is, I would say, like filament warm, just gently warm. As you can see, I can very comfortably keep my hands or my fingers on this, so I imagine there could be something haywire with the B+. Maybe the B+ is low. Again, this is a home-built power supply, right? So who knows if this was even done properly from the beginning at this point, right? So I hear nothing in the speaker, so I'll just back this out and bring this up to my ear. Yeah, there's nothing coming out of the speaker at all. All right, let's speed this process up. Let's see what is going on with this radio receiver. So I'll put this here. Hopefully that'll stay. I'll connect the ground, and let's see if we have any life. So still nothing coming out of the speaker. As you can see, everything is still hooked up. You know, nothing is happening. I don't know if you can see that in the background. Speaker's still here. Everything's hooked up. Nothing is happening. So let's turn this on. So the receiver is alive, so we know there's something's going on here. Still nothing coming out of the speaker, and I had to turn the volume down. So that's hearing the audio come right off the tube. So this is the audio that's the audio transformer right here. So I wonder if there's anything in the speaker leads? So there's audio in there, but there's nothing coming out. That's really odd, right? Huh, very strange. So I will go grab a jack here. Let's just try a different jack. See, plug something in the front maybe. These are the speaker jacks here. They're covered, headphone jacks, whatever you want to call them. 1/4-inch jack, that would be a good thing to call it. Let's plug this in. And let's see if we have any audio there. So I'll turn this down so it doesn't get confusing. If something does happen, let's see, turn that around. Oh, so we have audio here. Not very much. It starts to howl right about there. Now, yeah, that 6v6 is just lukewarm. Normally, you can't even go near these things. You're like this. You know, that much is about as much as you can touch these things. They're so hot. This 6v6, I can rest my fingers on it. So the B+ must be low in this thing. And yeah, that's the pure indication. Let's see if any of the RF amps or anything. Yeah, that's just finger warm. Oh, the mixer tube is just, yeah, comfortably warm. About as warm as the audio output tube. So yeah, so the B+ has got to be low or something going on with that, right? That would indicate the howling. So we heard the howling in the ultra probe, right? So that would indicate what's going on there. So that's really strange. So we have audio there, right? So, but nothing here. But yet it's hearing audio in the cable. So there's audio in the cable, it's just not getting to the speaker. So that would tell me that there's something maybe wrong with the jack. That is weird, isn't it? So put this back on again. Yeah, see. Nothing there. Nothing at the jack yet. You know. Yeah, there's audio in the cable. So we see audio here. Nothing here. Or very low. So there's got to be a break in the jack here, is what I would figure. Let's find out. Turn that off. Don't need to be listening to that. Let's find out here what's going on with this. Looks like it might be okay. Let me see closer up. Let's zoom into this. I'll use the monitor. Same thing that you're looking at. I'll move the focus here so I can kind of see what I'm doing right in the middle. Oh, look at that. It is broken. There we go. So that's supposed to be attached to that. So that's our problem. So at least with the speaker at any rate, that's the issue. So I wonder if I can just, well, here, let's just try it out. I'm pretty sure, obviously, it's, you know, broken connection. So let's see if we get anything happening here when we attach this. Turn the volume up. Is it going to touch? Maybe I'm not making connection still. Oh, doesn't sound like maybe. Or maybe the wire's too far back up inside here. Maybe it broke, and that might be the reason it had too much tension on it. See if I can. Yeah, see, it's pulled way back up into the jacket. That's kind of interesting. So maybe it was just pulled too tight. What I'll do is I'll just grab a pair of clippers from here and see how far back up in that jacket it is, because I pulled a bunch of that insulation off just right now, right? Just pulled a bunch of that. Well, there it is. And it's still not even there. So that's a ways up there. Oh, okay, there. I got some, yeah, that's pulled way up there. I don't even know if I can make a connection with that. That is really. Pull a bit more wire down, maybe. There is just no way I can get that to touch. There you go. So that's obviously the reason. It was probably too much tension and it pulled back. So let's just make a connection with the clipper. How about that? Let's see if that does it. There it is. So there it is. Yeah, it should have lots of audio drive power, right? But it's just, this thing is just running so, yeah, it's not even warm. So we do have life, which is a good thing. So what we could do is just ignore this cable and just plug it into the front here until we come across the point of having to fix the audio cable. I might even change that out, just to put a different audio cable in there. See how that works. So look at that. We're already starting to see some life out of this. It's nowhere near where it needs to be, but you know. Boy, sure not a lot of audio drive. That's a pretty quiet. Man, that is so. Yeah, definitely cool here. All right, so let me get a meter set up, and let's just check some B+ voltages and see what's actually going on in this thing. All right, this is the meter that we're going to be using to read the B+ inside this radio receiver. So I've got the negative lead attached to the chassis, and the positive lead of the meter is right here. The B+ for this radio is available on the audio output transformer. So one side is the power supply, and the other side is the plate side, or the anode side to the tube. We should see some drop across this if the tube itself is pulling any current. Since it was making audio, I imagine it most likely is. So we heard the audio here come out of the Carlson Ultra Probe here, which is this device. And by the way, if you're interested in this and building one of these things, all the plans to this device are in my Patreon electronics course. So the printed circuit board layouts, the drill files for the artwork, even the artwork to make this exact device is all available right in my Patreon electronics course. You definitely want to check that out. I've never really taken the time to demonstrate this here, like do a full demonstration on my regular YouTube channel to show you how well this thing works. If you're interested in seeing that, and if I get enough requests, leave a comment below, and maybe I'll just do a dedicated video to the Ultra Probe. Works great for detecting RF, works great, you know, working in IF sections of radios, works great detecting audio. As you see, you can just hold the probe right up to the cable and it hears the audio right out of the cable, or just above the tube even. And it even goes beyond that. You can use this to detect bad bearings, so it works in the mechanical world as well. So another one of my creations that I've released on Patreon, so definitely check that out. I'll put the link to my Patreon electronics course just below the video's description under the Show More tab, and I'll also pin the link at the top of the comments section. So if you click on that link, it'll take you right there. I'll talk more about this at the end of the video as well. So definitely a beneficial device to have in the toolbox. Oh, and you can check out the Mr. Carlson's Lab electronics forum if you want to see other people's, I guess you could say, versions of the case of this. So they've taken the circuitry I've designed, and some people have built it into their own project boxes and things like that. So you can see other people's take on the design of this as well. That's in the Mr. Carlson's Lab electronics forum. So check out mrcarlsonslab.com and just click on the forum and you're right there. Pretty easy to find. So lots of people have built this exact device, and of course they've built it in their own vision as well, using the circuitry design that I've designed. So there's a circuit that fits inside the probe here, and of course there's circuitry in the box itself. All of the plans for the probe and the box and everything are all there. So anyways, let's check out some B+ voltages. Let's see what we're at. So that is a little far away, so I'll zoom in. So I'm going to be contacting the probe here to this terminal here and to this terminal here, the second set down. And I have to warn you, if you're going to be following along, you're doing so at your own risk. Know that B+ is an elevated voltage, and all of these old receivers run at elevated voltages. So if you're following along, you're doing so at your own risk. All right, so the voltage there should be about 200 to 210 or something like that. So what I'll do is I'll zoom you into the meter here so you can see that for those of you with smaller devices. So this is the power supply side. So it is definitely low. We should have about 200 on the plate of the tube, so I expect to see a drop on the other side. So let's read the other side of the transformer. Yeah, 172. So that is quite a bit lower. So I know the circuit is drawing current. You know, we're pretty much from almost 182 to 172, right? So about a 10 volt drop there. So it is pulling current, but the B+ is low. Now, of course, more B+ makes the receiver definitely quite a bit, I guess you could say, hotter in many different ways. So what's actually happening here at the tube itself, I'll zoom you down here. So it's actually happening at the tube itself right here. It might even be lower than that. There might be something going on. So behind this panel here is a whole bunch of circuitry and stuff that may need to be replaced out in the actual full restoration that we're going to perform here. So you can see 181, that's on this side. See there on the meter right here. And then on the other side, which is this side right here, I don't know if you can see that. Try and get this in here to show you at the same time. You see 172. So, and that's these terminals down here. Now, this here is a homebrew power supply, right? Because these things came with dynomotors. So a dynamotor is basically an early DC to DC converter kind of thing. So basically it's, you'll take 24 volts or whatever voltage you have that's running into the unit, and it'll spin up a motor, and then on the second side of the motor it steps the voltage up. So you have two commutators. So the first set of commutators drives the motor, and then you have another winding inside on the armature itself, and it's got two sets of commutators, and on the other, on the other set of brushes comes the B+ on for the other side. So the whole idea is not to have to listen to a dynamotor. So because they sit there and they buzz all day, it's kind of neat, but they are loud. When you're in a plane, like this thing would have been on a B-17 or maybe a B-29 or something like that, if it's on a plane, you're not really worried too much about it because you're probably not hearing much over the noise of the engines itself, right? So you probably wouldn't hear that. But if you're listening to this in a quiet radio room or something like that, the dynamotor does tend to get a bit nauseating. So people make power supplies for this one, and this one here is made with two transformers. And if we look at the bottom of this here, let's get rid of the antenna. If we look at the bottom, you can see that it is a relatively modern design. So I'd like to put something a little bit more era specific into this, maybe with a directly heated vacuum tube rectifier, something that looks a little bit more air specific. I have another BC-348 that is a parts unit that has a very nice looking power supply in it. So what I think I'm going to do, what I am going to do is I'll pull this power supply out and I'm going to put the vacuum tube power supply in here. So I'll share that entire process with you as well. There are B+ voltages available at this jack right here on the back, and there's pins sticking out, so I'll probably end up removing this as well. And just going through and making this thing work the way it was supposed to when it rolled off the factory floor, aside from the dynamotor, right? Because we don't want to be listening to that. We want this to be friendly in a nice quiet radio room kind of thing. We want to just listen to the radio receiver, not the whirring of a dynamotor. So all of that will be coming in the next episode. In fact, I would like to keep this entire restoration to 2 parts. So this is the first part. So I'm thinking in the second part, I'm hoping to have this entire thing done. So the second part will probably be, relatively long, because this is a pretty in-depth restoration, but it will be coming up very, very shortly. And in fact, I've got the radio with the power supply ready to come out right off to the side right here, right now. And I'll be working on that as soon as I shut the camera off, and I'll be basically turning it back on again, starting with part number 2. So there you go. That'll be coming up very shortly. If you haven't subscribed, you're definitely going to want to do that now so that you'll be notified as soon as I post the second part, so you get to see how well this old radio receiver actually performs. I'm sure we're going to hear signals from all over the world. If you're interested in learning more about electronics, if you'd like to troubleshoot and repair electronics, modern and antique stuff, you're definitely going to want to check out my ongoing electronics course on Patreon. I also have the plans for the Ultra Probe there, so that's everything. Schematics, circuit designs, printed circuit board, layout designs, everything is there, with instructions on how to build it and all the stuff in between. I have many, many projects on Patreon that you've seen here on my regular YouTube channel. I've designed and created so many different pieces of test equipment. They are all there for you to build and enjoy, so definitely check it out. I'll put the link just below the video's description under the Show More tab, and I'll pin the link at the top of the comments section. So if you click on that link, it'll take you right there. If you're enjoying these videos, you can let me know by giving me a big thumbs up. Hang around. There'll be more videos like this coming in the very near future. We'll be doing lots of repairs and even circuitry design, troubleshooting videos, all sorts of stuff in between, restorations and all that great stuff. So stay tuned. So if you haven't subscribed, definitely do that now. All right, until next time, take care. Bye for now.